Welcome back to this fun-filled edition of College Trigonometry Online. So let's go ahead and jump into 9.2. Let's start looking at some of this trig information. Also, if you noticed by the notes, I have also put in another set of notes called unit circle. You're definitely going to want to have that unit circle, have those notes, either print them off or have them ready to go. When you open those in the PDF, it's kind of sideways. So you just go up to your view and rotate the view counterclockwise. And there we go. There's the unit circle notes that I gave you. You're definitely going to want this for this section to help you out. Okay? So let's talk about the unit circle. So the unit circle has some trigonometric formulas that we're going to look at here in a second. The reason why we call this a unit circle is because all the angles, the terminal rays and the initial rays that make them from the origin to the side of the circle, all the radius are, or radii I should say, are 1. Okay, a distance of 1. So you can see that with this point 1, 0, because from the origin to this point, that is the point on a graph of 1, 0, and then 0, 1. So all of these, if I drew in a radius here, all the way out to pi over 6, that would be a radius of 1. Okay? So that's what you're looking at when we deal with this information. That our radii on the unit circle is 1, hence unit. Unit meaning 1. Okay? So like I said, we have some formulas here. You're definitely going to want to have these things written down because they are important to us. Very, very important. This is how we're going to get through this section because a lot of your answers in this sections are going to be exact answers. There's going to be no rounding unless the directions say, but for most of these directions it says give me the exact answer. So sine theta is equal to whatever the y value is. Cosine theta is equal to whatever the x value is. Tangent theta is y over x. And then down here, maybe you knew about these, maybe you didn't, but here we have cosecant, secant, and cotangent. They are the reciprocals if you kind of look at this, because underneath the y there's a 1 that's there. Okay? And if you flip that, take the reciprocal in other words, that's what cosecant is. Secant is the reciprocal of x, because again, like I said, there's a 1 under the x. And if you take the reciprocal of that, it becomes 1 over x. And then cotangent is the reciprocal of y over x. How I kind of keep these straight, how I remember that secant is the reciprocal of cosine, and sine is the reciprocal of cosecant. Cos only go with one type of angle. So I will never say that I have cosine and cosecant. See, those are two cos. Okay, you never pair up two cos. Okay, so no cosine, no cosecant. So when I think about this, sine, what's the reciprocal? That's cosecant. Cosine, what's the reciprocal? That's secant. Okay, see how it's not, there's only one co for these pairs. For sine, it's cosecant. For cosine, it's secant. And then tangent and cotangent. So think about it as when you're trying to put these things together, you never have cos, two cos as reciprocals to each other. That doesn't make any sense. No two cos, only one co per pair. And then down here, this is the formula for a circle that is centered at the origin. X squared plus y squared equals 1, because the h in here is 0, the k in here is 0, and the radius is 1. And then down here, we got a nice little Pythagorean triple that we can talk, or Pythagorean theorem identity that we can talk about. Okay, this also looks like a squared plus b squared equals c squared. Okay, so a lot of this is going to be related to circles in trig. A lot of it's related to circles and triangles. You'll see that. So we call this a Pythagorean theorem identity. And it makes sense because x, well, x is cosine. So this is just cosine squared. All we did was plug in the cosine to x. Y is sine. So if we plug sine into y, we get sine squared, and then you got 1. So nice little Pythagorean identity using what we know about these formulas for the unit circle. Okay, so we're going to be using these. So keep these in mind as we start going through this. So let's take a look. So one of the questions it's going to ask you, it says, determine the fraction of the circumference of the unit circle. So in other words, they want to know how much of the unit circle is pi over 3 taking up. Okay, they want the fraction of it. Because it's not obviously taking up a full circle, it's taking up a part of it. So in order to get to this answer, all they're really wanting you to do is take the radians that you got here, and they want you to multiply it by 1 over 2 pi, if you're thinking like a fraction, or just take this and divide it by 2 pi. All that will give you the same answer, and you can actually go to your calculator and plug in the pi's for this when you do it. Okay? Or you could just think about this as all we really want to do is take pi over 3 times 1 over 2 pi. We've kind of dealt with this situation. Or remember, these are just fractions. 1/3 times 1/2. Okay? What's going to happen is the pi's cancel out, like what you've seen in 9-1 happen when we were converting from radians to degrees. And then really all it is 1/3 times 1/2. Hopefully you remember how to multiply fractions in your head, but if you don't, remember you got your handy dandy calculator, and that gives you 1/6. That's what they're after. So pi thirds, okay, pi thirds is 1/6 of the unit circle. That's what they're looking for. Just want to know how much it's taking up. Okay, remember S means arc length. Okay, so it kind of going back a little bit to 9-1 here. So an arc length of pi thirds is 1/6 of the unit circle. There you go. So now we're actually going to jump in and start using some of that information we know about. Right now, we're only going to focus in on the first 3 trig functions. These are like the big 3. We like to know about sine, cosine, and tangent more than anything. So when you deal with this, remember that in the beginning it said that sine is whatever y is. Well, this is a point. Points are made up of 2 variables. They're made up of x, and y. So if I want to know what sine theta is, all I need is the y value, which is 12/13. And there you go. Cosine is made up of the variable x. So if I want to know what cosine theta is for this point, we've got -5/13, because that's the x value. Tangent down here is made up of y over x. Well, all we do is plug in our y values, so 12/13 divided by our x value, which is -5/13. Okay, and then you can just go straight into your calculator and divide these 2 fractions. You know how to do that. It's not that hard. Or if you can remember that we don't really divide by fractions. What you do is you multiply by the reciprocal. So we change division to multiplication. Remember, keep, change, flip. Keep the numerator, change the division to multiplication, flip the denominator. So -13/5. That's really what you're multiplying by, or what's really going on here. Because division does not exist. Division is just multiplication in disguise. So if we actually multiply all this out, or if you go to your calculator, because it doesn't bother me one way or another, you get -12/5. There you go. It really is that easy. That's what we're doing right now. Because we're on the unit circle, it makes things really, really easy for us. Okay? You just got to follow those simple formulas. A lot of trig is following those formulas. Okay? So there you go. That's it. Go ahead and try this one on your own. So they're telling you that you have pi over 2. Okay? remember that pi over 2. And if you don't like working in radians, guys, remember I always told you what I told you in 9-1. You can convert that into degrees, and then you can go to your unit circle and look at this stuff. So go ahead, pause the video, give these three a shot. All I did was provide you a picture over here of the unit circle. Okay. So if you looked up pi over 2, really that's 90 degrees. Hopefully some of these will start to stick in your mind. And pi over 2 is right here. So this is the angle that you're looking at. Okay? And that point right there is the point 0, 1. And now that you know what the point is, you can answer all the questions that are over here. Easy peasy. Okay? So hopefully you said that sine of pi over 2 is 1. Hopefully you said cosine of pi over 2 is 0. Because remember, sine is the y value is 1. Cosine is the x value is 0. And then down here, this is y over x. So that is 1 over 0. But we do not write 1 over 0 because we cannot divide by 0. So we call this undefined. Okay? So if you have 0 in the denominator, your answer is undefined. Be careful with that, because there's a difference between 0 and undefined. Okay? So anytime you have a number over 0, kick out the word undefined. That's what they want. All right, easy peasy, right? Do it again. Okay, so if you look at this and you looked at the unit circle, you know the circle goes from 0 to 2 pi. Okay? But we have negative pi or 8 pi. That's a problem. Hopefully you're thinking back to 9-1 when we talked about coterminal. Let's figure out what the least positive coterminal angle is. Or at least get an angle that's on the unit circle, because negative 8 pi is not on the unit circle. So this is what I was talking to you about in that 9-1, where we need to use coterminal angles to help us. I told you, coterminal angles are so important for us. Okay? So to get coterminal, all we're going to do is we need to make this positive, so we just got to keep adding 2 pi. So if I take 8 pi plus 2 pi, I get negative 6 pi. Nope, not there yet. So let's add 2 pi again, and we just keep adding till we get where we need to be. So plus 2 pi. Well, that gives us negative 4 pi. Not there yet. So let's take negative 4 pi and add 2 pi. Well, that gives us negative 2 pi. Still not there yet. We're not on the unit circle yet. Well, let's negative 2 pi, add 2 pi. And that gives us 0. There we go. Now we got something on the unit circle. Now we can work with this. So we know that our angle looks like that. The terminal and initial ray are right there on the positive side of the x-axis, and we know that we're dealing with the point 1, 0. And now you can answer your questions. Hopefully you did something like that. Hopefully you thought coterminal. If not, now you've got all the information you need. We know that negative 8 pi is the same thing as if we run sine of 0. Cosine of 0 here. We're going to get the same answer because it's the same angle. Tangent of 0. So go ahead, get these answers now. Okay. So hopefully you said sine is all about the y value, and our y value is 0. Cosine is all about the x value. The x value is 1. Tangent is all about y over x, so that gives us 0 over 1. Now this one is an answer of 0. And there you go. Easy peasy. But you had to do a little bit of coterminal first. So don't forget about coterminal angles. They're going to throw those at you in here. Okay? So you either have to add 2 pi or subtract 2 pi. Notice there's a lot of radians in this. Again, You can turn these into degrees and then figure out what point you're working with. It's all the same. Okay? So, here is the arc length they're giving us. So, negative 17 pi over 2. All right? So, again, that negative 17 pi over 2, and I said arc length, it's also our angle that they're giving us. So that negative 17 pi over 2, again, it's not on our unit circle. If you look at it, all of our angles on the unit circle are positive. So go ahead and apply some coterminal to this and do this one. Now notice they're also giving us the other 3 trig functions. So now we're looking at all 6 trig functions. Remember that cosecant, secant, and cotangent are the reciprocals to the ones that are right across from them. So if you can get the big 3, you can get these 2 because all you got to do is flip them. And there's your answers. So I would work on the big 3 first. That's why I focused in on those first. And then to get the last 3, all you do is flip it, flip it, flip it. Okay? So go ahead, pause the video, give it a shot. Okay. So the first thing is we got to turn this into the least positive coterminal angle. Okay? So we're going to add 2 pi. So I'm going to go to my calculator. I'm going to take negative 17 halves plus 2 because I got to know what this is as a fraction. Okay? I got to make sure that it's between 0 and 2 pi. So that gives us negative 13 pi over 2. Not quite there. So let's take negative 13 pi over 2 and add 2 pi. Because we're not there yet. So negative 13 over 2 plus 2. So that gives us, sorry, I keep hitting the wrong piece, negative 9 pi over 2. Still not good enough. Well, let's take negative, let's do this. We'll grab this work right here. Just slide it right over here. There we go. So let's take negative 9 pi over 2 and add 2 pi. So that gives us negative 5 pi over 2. Still not positive. So negative 5 pi over 2 plus 2 pi gives us negative pi over 2. Still not there yet. So if we take negative pi over 2 plus 2 pi finally, this will get us our least positive coterminal angle. So add 2 and you get 3 pi over 2. So this is on the unit circle. That's what you want to work with. Okay? So this is the angle that we're going to work with in all of these. We're going to look at not sine of negative 17 pi over 2, but sine of 3 pi over 2. And cosine of 3 pi over 2. And tangent of 3 pi over 2. Because all these answers are going to have the same answers as the negative 17 pi over 2. So 3 pi over 2, the point for this guy is 0, comma, negative 1. And now you can start filling in all your answers. So sine is all about the y value, which is negative 1. Cosine is all about the x value, which is 0. Tangent is the y over the x, so that's negative 1 over 0, which for us is undefined. Okay. So over here, all we do is we take the reciprocal of these. So remember, if you have just a number, remember that it's the same thing as saying that that number is over 1. Okay, so if I got negative 1 over 1 and I flip that, that's still negative 1. Because what you'll have there is a positive 1 over a negative 1. That's still a negative 1 when you divide that out. Right here, I have 0, and it's over 1. And if you flip 0 over 1, you get 1 over 0, which that becomes undefined. And then right here, you already see what is in store for tangent. It's negative 1 over 0. And if you flip that, that gives you 0 over negative 1, which is just 0. Okay? See, not too bad. Hold on 1 second. Okay, it's fine. Oops. All right, so moving on. So right here, this ASTC. So what I'm talking about on this one is I'm going to give you an acronym so that you can know the signs of your trig functions, because this is going to be very, very important. Because you're not always going to have a picture of where your trig functions are at, and you should know the signs of them. And this is also going to be important for some other questions later on when we just talk about trig functions and whether they're positive or negative. So this ASTC, the acronym I want you to understand for that, so you don't have to memorize it as ASTC, is all, there's the A, students, there's the S, take, there's the T, calculus. Or if it's not calculus, call it chemistry. Okay? So ASTC. All students take calculus. This is a way to remember signs of your trig functions. So in quadrant 1 stands for the A, which represents all. In other words, what I'm telling you, in quadrant 1, all trig functions are positive. Okay? That's super important. Quadrant 1, everybody's positive. Sines, cosines, tangents, secants, cosecants, cotangents. Quadrant 2 stands for the S, which is the students, which means S standing for sine is positive. But since sine is positive, so is its reciprocal. And what's the reciprocal of sine? Cosecant. Yeah. I'm going to use the abbreviation. Cosecant. CSC. So in quadrant 2, the only trig function that is positive is sine and cosecant. Quadrant 3 stands for T, the take. And that means that in this one, it is tangent. And its reciprocal, cotangent, are the only ones that are positive in quadrant 3. And in quadrant 4, the C, which is calculus or chemistry, stands for cosine. And its reciprocal, which is secant, are the only ones positive in quadrant 4. So that ASTC stands for the positive trig values in their quadrants. So A, S, TC, and the STC are the big 3, sine, tangent, and cotangent. Cosine. And then remember that with sine, you have its reciprocal that has to follow suit of sine. Tangent has its reciprocal cotangent. Cosecant has its reciprocal secant. Okay, so that's what this is for. This is a mnemonic device. All students take calculus to help you remember signs of trig functions in the different quadrants. Okay? All right, so go ahead and pause the video and see if you can try and find these exact values. Okay, so instead of finding all 6 values, now we just want you to find one of them. Okay, so sine is all about the y value, and this is where you need to have that unit circle handy for you. So you're going to go out to that unit circle and you're going to find 5 pi over 3. Okay, so we go out to our unit circle, we're looking along here, 5 pi over 3, right there, there's the point, 1/2 comma negative square root of 3 over 2. Okay, 1/2 comma negative square root of 3 over 2. 1/2 comma negative square root of 3 over 2. Over here, 7 pi over 6, let's go ahead and get that point. So 7 pi over 6 right here. So it's negative square root of 3 over 2, comma negative 1/2. So we got, come on, negative square root of 3 over 2, comma negative 1/2. Okay? So then all you do is just use this point and what you know about sine and what you know about cotangent to make your answers. Okay, sine is all about the y value. So the answer to this guy is negative square root of 3 over 2. Plain and simple. Cotangent is all about x over y. So if we write this out, you've got negative square root of 3 over 2 divided by negative 1/2. Now you can't go to your calculator to help you out with this one because of the square root. Whenever you have square roots in there, you're going to have to be able to do things by hand. So, and I showed you earlier how this works. We don't really divide by fractions, we multiply by reciprocals. So what's going on here is that this is the negative square root of 3 over 2 times, because division becomes multiplication, flip this, negative 2 over 1. Okay? So when you multiply fractions, remember that these two are going to kind of cancel each other out because one's in the numerator, one's in the denominator. That's some college algebra stuff, you know, canceling. Negative times a negative is a positive. So in the end, you really have just the square root of 3 on top over 1. That answer is fine, but you can also just call it the square root of 3. We generally don't write stuff over 1. So that's the exact answer that they're looking for. Okay? Also remember that you might have some radicals in the denominator, so you might have to be doing some rationalizing. Rationalizing is pretty important in trig. So there's going to be some times where you might have to rationalize. So don't forget about rationalizing. And there you go. That's all these problems were about. Instead of finding all 6, we'll just make you find one particular piece in general. And then you just look up the point on the unit circle and then follow your formula. All right, here's where it's good to know some of that information about sines. And let's see here. Yeah, not too much left. All right, so right here, the very first thing that you have to do in order to find these 6 is we've got to figure out what x is. Well, this is why we have that x squared plus y squared equal to 1. This is where that Pythagorean identity, or Pythagorean theorem identity or unit circle information is going to come involved, because I want to know what x is. I have y, and I know that it's equal to 1, so we can plug in and solve. So we know that we've got x squared plus my y is 4 over 5 squared equal to 1. So again, we want to be exact. No decimals. They do not want decimals. So 4/5 squared is 16 over 25 equal to 1. All you got to do is subtract 16 over 25 from both sides. And x squared is equal to, let's see here, 9 over 25. How do you get rid of something squared? You square root it. Now, remember in college algebra, when you square root both sides, it becomes plus or minus. And thankfully, what we have here are nice numbers. The square root of 25 is 5. They're nice perfect squares. Square root of 9 is 3. But remember, you could have weird numbers here where you might have to rationalize and things like that. So don't forget also how to break down radicals, because you might be seeing some of that. Okay? Now, we can't have both of these. That doesn't make sense. That's where this little piece right here comes involved. This is going to tell you what is the sign of x. Okay? So this says x is less than 0, which means that x needs to be negative. So now we know that down here, when we're looking at this, what we really want is x to be negative 3/5. So they're going to make you do a little bit of work. Now we know that this is 3/5 negative. Now you can go through and find the answers. So the key was using this x squared plus y squared equal to 1, Pythagorean theorem identity, or the equation of a circle. Okay? So if you didn't get that far, if that part tripped you up, go ahead and pause the video and give me everybody else now. Okay, so sine is the y value. So that's, oops, let's put my pen back in the right mode. 4/5. Cosine is the x value. Well, we just figured that out. That's negative 3/5. Tangent is y over x. So that's 4/5 divided by negative 3/5. And again, we've had long conversations about this. You can go to your calculator and actually use your calculator for this one. That's a-okay, because there's no radicals in it. But really what's going on is you're taking 4/5 times a negative 5/3, because you keep, change, flip. And in the end, you get negative 4/3. So all we do to get the other 3 is flip, flip, flip. So cosecant is 5/4, because it's the flip of sine. Secant is the flip of cosine, so that's negative 5/3. And then we flip the tangent, which gives us negative 3/4. And there's all 6 answers. See, you got this. Nothing crazy. Easy peasy lemon squeezy. All right, go ahead and pause the video and try this one. Okay, so hopefully you realize that cosecant and secant, we can do those real quick because we already know sine and cosine. Okay, remember that these are the flip of each other. So cosecant is the reciprocal of sine. So that gives us negative 25/7. And always make sure that your fractions are reduced. That's always understood. We always reduce fractions, but I want to make sure I reiterate that. Secant is the reciprocal of cosine, so that's negative 25 over 24. I about just put 4. Now, to get the other two, well, think about what they're giving you here. Remember, this is sine, so that means that this is the y value of a point. This is cosine, so that means that's the x value of a point. We can go backwards with some of this information. So we know that we have a point that is negative 24/25, comma, negative 7/25. And we can use that to our advantage. So we took it back, and now we know what the point looks like, and now you know how to do tangent and cotangent, because tangent is y over x. So that's negative 7/25 all over negative 24/25. Okay? And again, just going back, this is really just negative 7/25 times, because division becomes multiplication. Flip it, 25/24, of course, negative. And that gives us, a negative times a negative is a positive, the 25's cancel, 7/24. And I don't believe that reduces. Let me just double check. Oops, 7 divided by 24. Put it in the wrong number. Yep, that's good. So if I want cotangent, all I do is take the reciprocal of that. So 24 over 7. There you go. It's just throwing the same information that we've been doing throughout this whole thing at you different ways. That's all these last few questions are. And we got one more, very, very simple question. This is where you need to know that all students take calculus, or all students take chemistry. Okay? So they want to know which quadrant satisfies both of these. Okay? So what you're going to do is you're going to find the quadrants for each one of these separately. And then whatever quadrants they share in common, that's the answer. So again, remember that this is all students take calculus. Okay? So cosine is in the fourth quadrant. That's where it is positive, because that's what this says. Give me the positive answer. So it's positive in the fourth quadrant, and it's also positive in quadrant 1, because all trig functions are positive in quadrant 1. So we're going to write down quadrant 1, quadrant 4, because that's where cosine is positive. We're positive in quadrant 1 because everybody's positive. And we're positive in quadrant 4 because that's what the C stands for, cosine. And this is the positive quadrant for cosine. Okay? Down here, so secant, you have to remember who is its reciprocal. The reciprocal of secant is related to cosine. Okay? So whatever cosine does, secant does. Well, we already know those answers. Okay? Secant is positive, because that's what this says, positive in quadrant 1 and in quadrant 4. So, what quadrants satisfies both of these? Well, they both share quadrant 1 and quadrant 4. And that's how this is done. You only answer with what they both have in common. Sometimes there is nothing in common. Sometimes there's only one quadrant. Sometimes there's two. Okay? But that's where that ASTC comes into play for this guy. Helps you out. Okay? And that, my friends, is section 9.2. Coming up next week, we will start looking at graphing these trigonometric functions.